Hi, my name is Zeyuan Huang from the Institute of Software, Chinese Academy of Sciences. In this presentation, I'm going to talk about our fall paper, SpeechMirror, a multimodal visual analytics system for personalized reflection of online public speaking effectiveness. This work was completed in collaboration with researchers at Diatom Design, Tsinghua University, Cardiff University, and Northumbria University. In recent years, we have witnessed a significant increase in online communication. However, there are many differences between engaging with remote audiences compared to face-to-face interactions. Online speakers often face challenges in effectively connecting with remote audiences, leading to confusion and uncertainty. We identify 2 points that speakers are often concerned about. Firstly, if their speech performs well, and secondly, wondering how to improve. There is a need for analytical systems for online speeches to mitigate these issues. So our goal in this work is to allow a speaker to reflect on their speech with guided insights from a collection of speeches and discover further possibilities for improvement. We utilize the speech data from the World Championship of Public Speaking, which encompasses different levels of significant variations in performance. We took the contest level as a metric for evaluating speech effectiveness. We began reviewing existing literature and providing domain interviews. In the literature review, we aimed to construct a set of potentially relevant speech factors and identify the unique characteristics of online speeches. Through interviews conducted with 6 domain experts and amateurs, we gained insights into their understanding of speech techniques, current methods, and challenges in developing presentation skills and their requirements for an analytical tool. With the insights from literature and interviews, we established 5 key considerations for our design. Based on the user requirements and feedbacks, we built a visual analytics system with data processing and analysis workflows. First, we collected 102 online videos from the International Speech Contest. We extracted multimodal features from these videos and aligned them based on time. In particular, the use of eye contact and position in the camera frame are important factors in online speeches, and previous work have not extensively addressed. We further calculated speech effectiveness factors and examined their correlations with speech effectiveness. We used multi-class ordinal regression to get the calculated effectiveness and factors. To assist the user to further discover possibilities for improvement, we designed a module that recommends similar and different speech samples. The module recommendation can be based on script content or on the speech factors. Recommendations can also be for the entire speech or sentences in the speech. We created an intuitive visual interface, which I'm going to introduce later. We designed our system and iterated our designs as we received feedback from potential users. We used a set of design principles to minimize the cognitive load for users who may not have a background in visualization or statistics. In our system, we utilized certain elements repeatedly, including icons representing speech techniques and color mapping representing speech factor effectiveness. Our visual analytics interface consists of 4 panels. The factor panel provides an overview of speech factors in the speech. It shows the distribution relationship between the analyzed speech and the speech dataset. Speech factors are characterized based on speech techniques, and their effectiveness is represented by color. A histogram displays the distribution of the current speech factors compared to the best speech factors. By interacting with the panel, users can hover their mouse over a specific speech player to view more detailed data and charts. Selecting one or multiple speech factors in this panel will filter and update the data visualizations in other panels. The speaker panel offers an enhanced video speech player that combines the speech video context with the key speech factors. Users can watch the video while observing the changes in speech factors, facial expressions, eye gaze, body movements, and on-screen positions are overlaid directly on the video. Interactive features allow users to explore more detailed data and access corresponding recommended videos. Time Slice panel enables users to select a segment of the speech and displays the data distribution and corresponding speech content within the selected part of speech. It consists of 3 components. The progress bar displays the effectiveness of 3 speech factors and pauses between sentences. Users can explore and navigate this video by selecting parts on the progress bar. The distribution charts of the speech factors and multimodal features show how they evolve over time, along with the accompanying text. The mirror panel provides a multimodal summary of the selected segment of analyzed speech. We introduced a visualization approach called Speech Twin, which will be explained in detail later. Users can quickly access reference speeches and perform comparisons on the recommended speeches. Users can manually switch between recommendation modes and recommendation levels on the interface. When hovering over a speech example, users can see the differences between that speech and the currently analyzed speech for comparison. These panels are tightly interconnected, and the interface provides multimodal interactive features to ensure coherence and intuitiveness of the interactions. Users can select different speeches for focused analysis. Speech Twin is an innovative visualization approach we introduced in this work. It draws inspiration from the use of masks in different cultures, where facial colors, shapes, and exaggerated expressions represent the characteristics of characters, such as in Chinese opera or ancient Greek theaters. After several designs, we developed a digital twin summary of the speech, hence the name Speech Twin. We mapped the multimodal speech data onto different parts of the small person so that users can directly have intuitive insight into factors, such as the footprint of the person indicates the position and the direction of its mouth indicates the emotion. By summarizing over time, we are able to overcome the challenge of gaps in the data of different modalities. Speech Player, which is the main component of the speaker panel, enhances the video player by directly displaying key speech techniques on the video. It also visualizes the changes in body gestures and eye gaze over time, providing convenient access to the spatial and temporal context of presentation techniques. We designed corresponding feature visualization methods based on the characteristics of different modalities. These methods allow users to understand the temporal changes in multimodal features and relate them to the changes in speech factors. We conducted user study to evaluate the effectiveness and usability of the proposed system and visualization methods. The study consists of 3 stages, from introduction to exploration and to reflection. Based on the user experience, scales, and interviews, we summarized several points that users appreciated and areas they felt needed improvement. Users generally found our system valuable for providing speech factor analysis and appreciated the recommendation feature. They recognized the value of the visualization methods proposed in our system. Users provided many potential applications that we had previously not considered. However, users also mentioned some areas for improvement. They found our system to be overly complex, with statistical charts in the factor panel being difficult to understand for users without a foundation in the topic. They also noted that the text-based recommendations were not always accurate and that the display of the text context was fragmented and not intuitive enough. Based on the usage patterns of the participants, we distilled 2 typical case studies that demonstrated users' acceptance of our system and their ability to derive valuable insights. Due to time constraints, we can recommend the audiences to watch the case study supplemental video provided with our paper for detailed information on these cases. In this work, we have developed a visual analytics system for providing feedback on the effectiveness of online speeches. We propose novel visualization methods to integrate multimodal role features and speech factors. Through our experiments, we observed good usability of the system, and users were able to gain insights using our system. We aim to present speech feedback through our system like a magic mirror, where users can clearly see their strengths and weaknesses and also observe the situation of others. Mirror, mirror on the wall, which is the best speech in the world. There are still many questions to explore and further research in this domain. We are continuing to expand our database and conduct more research. We welcome those wishing to collaborate together. We sincerely thank the public speaking experts and amateurs for their support for our study. We hope more research and platforms to help people express themselves more effectively. Thanks.